Okay, we are going to review how to calculate an empirical formula right now. So what I have is on the board, I have a particular set of data. We have a certain substance that has 71.65% chlorine, 24.27% carbon, and 4.07% hydrogen. Its molar mass is 98.68. So I have two questions. What is the empirical formula of this substance? And what is the molecular formula of this substance? Now, in order to solve this, we're going to start with a relatively simple first step. We're going to assume a sample size. Now, with percentages, if we assume a sample size of 100 grams, this makes this relatively easy. So if it's 71.65% chlorine and I have 100 grams, then I have 71.65 grams of chlorine, 24.27 grams of carbon, and 4.07 grams of hydrogen. Now, I can't compare the masses directly. I need to know the number of particles. So we're going to convert from grams to moles. And I know that 1 mole of chlorine has a molar mass of 35.45 grams. Okay. 1 mole of carbon is 12.01 grams, and 1 mole of hydrogen is 1.008 grams. So this gives us our moles of each of these. Now, going to my handy dandy calculator, I actually punched these in ahead of time. So this is 2.021 moles of chlorine, 2.021 moles of carbon, and 4.04 moles of hydrogen. Notice that the hydrogen only had 3 significant figures here. I will end up with 3 significant figures here. Always use the maximum number of significant figures that you have, not everything that's on your calculator. Now, this tells us that for every 4.04 moles of hydrogen, I have 2.021. So what I'm going to do is I'm going to go through and I'm going to divide all of these by the smallest value. This particular one is 2.021. This is 2.021 divided by 2.021. Now, I don't need a calculator to take 2.01 divided by 2.01. That gives me 1. This one also gives me 1. This one, 4.04 divided by 2.02, that gives me 1. Your calculations don't always end up that simple. However, you're going to end up with a relatively whole number ratio, although you may get a fraction. We'll talk about that here in just a moment. But in this case, chlorine is 1, C is 1, H is 2. And again, I don't need to write the ones, but I'm going to anyway. Now, this, if I look at it, does not have a molar mass of 98.68. If I add 1 chlorine, 1 carbon, and 2 hydrogens, 35.45 plus 12 plus 2, and that gives me a total molar mass of about 49.48 grams. Not the same as this one. So what I'm going to do is I am going to take my molar mass divided by the mass of my empirical formula. This one will give me a whole number ratio. If not, you have made a mistake in the problem. So 98.68 over 49.48. This gives us about 2. So that tells us there are 2 empirical formulas in the molecular formula. So I'm going to have Cl2C2H4. And that is my molecular formula. This is my empirical formula. Now, just as a simple reminder, if you go through this and do the calculation and you end up with something like 2.5 when you divide one of them out, 2.5 is not a whole number, so you'll have to multiply everything by 2. If you end up with like 1.33, you're going to have to multiply everything by 3. And that is how we do an empirical formula.